Welcome to this beautiful, beautiful penthouse. We got a little bit of sunset before we started, but now we are officially kicking off this panel. I will be your moderator. My name is Jules. I am a principal at Radical Ventures. Radical started in 2017. We're a focused AI fund. We're now investing in seed and Series A companies out of our early stage fund that's $600 million, and also Series B companies upward from our first growth fund that's $800 million. But the focus of the discussion today is going to be the future of human data and intelligence. And before we get started, maybe everyone can just introduce themselves. I know Micro One already has. Welcome, and maybe I'll pass on to Rob.
Hey everybody, I'm Rob, product lead at the San Francisco lab from Amazon AGI. We focus on computer use, browser agents, and everything else at the stack.
Hi everyone, I'm Arjun, co-founder of Cartesia. We build real-time foundation models for multimodal interactive intelligence, focusing on voice.
Cool, and I'm Kevin. I'm an applied scientist at Microsoft, working on computer use agents for Microsoft's M365 product for enterprise customers.
As you already went, I'll go again real quick. I'm Ali, founder of Micro One. What we do at Micro One is we're building the AI platform for human intelligence. We vet PhDs, highly skilled people in different domains, and we help train frontier models.
All right, obviously, we're pushing on all sorts of frontier for artificial intelligence. There's multimodal, there's reasoning, there's agent use. So maybe we can start with, where are you pushing on? What are the frontiers you're focused on right now? And maybe what kind of data do you find most helpful while you're pushing on those frontiers?
Yeah, happy to go first here. So I think the main focus that we have is post-training. I think a lot of labs are sort of quote-unquote done with pre-training, and they're heavily focused on finding strategies to improve their models in different domains using kind of post-training architectures. So what we do is we are providing the domain data in different domains such as finance, medical, legal, to help train models. So we're heavily focused on the bottleneck of data, and there's a lot of reasoning models with kind of rubric-based data points that we are heavily emphasizing.
Yeah, in terms of Microsoft's computer use agents, OpenAI has already released their computer use agent model, so you can imagine some of the post-training that goes on top of that. It looks like continued RL. And for RL, for Microsoft, you might imagine you might want to do it RL on Microsoft-specific products like Excel or PowerPoint. And so those tasks, you need to create custom data for that, and so there's a lot of investment within Microsoft trying to create RL tasks for those.
Yeah, so at Cartesia, we're really interested in what does the world look like if you were to think about machine learning from an interactive lens. Voice specifically is one of the main mediums of conversation, right, or interacting with the world around us. When we build our models, we build them from scratch, and so we're thinking both about the pre-training as well as the post-training. Voice is like a very new modality, right? It's, I guess, existed forever, but it's something that folks are really focusing a lot more on. But really, what are the kinds of experiences that you want to be able to deliver to your users, right? That's where a lot of the thought goes into when you think about where's your data coming from, what are the ways that you want to post-train your model. So yeah, I'm really excited to talk about some of that today.
Yeah, and here at the lab, we're really focused on computer use agents, very similar. What we're really starting with is the basic understanding of UI elements. Does this model, it doesn't really see it in pre-training. So we're focused on the whole stack. How do we introduce pre-training? How do we then introduce post-training? How do we get it to understand the way that we all take for granted, that you can do things like drop down, click an element in a calendar invite, pick a seat in a stadium. These are all really difficult for models today. And so we're pushing both pre-training, post-training, as well as RL environments to try to teach these models how to operate UIs in the same way that we do.
Very cool. Obviously, in the AI world today, we're seeing a lot of very large number thrown around when it comes to capital commitment. So maybe for folks here, when do you know how to and when to scale your data commitment? When do you know, okay, this is starting to work and the more data I put into it is going to start to really scale? What is the signal or indicator you're looking for?
Yeah, I think oftentimes there's there's a lot of experiments that have to be ran. I think a lot of the main focus of researchers right now is coming up with different data structures that are efficient ways to train models.
and oftentimes they're oral environments, sometimes they're more static human data environments, and you essentially have to figure out different taxonomies of the similar data, and once you get early signal on model improvements, you essentially double down on the amount of data to be collected with that specific taxonomy. So that's kind of the general structure of starting with an experiment and then you scale it up once a certain taxonomy works.
I guess I'll just double click on that. I think that's exactly how we do it as well in terms of we run early RL experiments on kind of smart data sets, make sure the structure looks okay, see that we're seeing early gains, and once we do that, then we think about how to expand, particularly in areas of diversity and maybe difficulty of the tasks that you might imagine.
Yeah, I mean, I think data is something everyone always has to invest in, right? You can't skimp on it. I think when you're thinking about scaling, you're really looking at what are the capabilities, right? That you're actually trying to evoke right out of the model. Sometimes you don't see those capabilities until you've invested enough capital in order to get that data, right, or scale up your model. I think something that's very interesting, through model training, is really understanding where the data modeling interface actually lies, right? I think there's often been a wide debate of, is it data, is it the architecture? People keep asking the question. I have no comment, but I do think it's actually very important that you have almost this way of feeling out how your data is, understanding what are the subtleties of your data, because that's actually what allows you to figure out, right, should you be scaling, how you should be scaling, and a lot of these, whether it's human data, synthetic data, right, there's just so many different ways of thinking about that.
I'll just double down on that. Also point out that you've definitely made a bet on architecture versus data. But yeah, I think what I've seen so far is the smallest amount of data you can possibly get to start seeing changes in the model is the starting point to then evaluate if you're going the right direction. And it's never a question of should you do more, it's more a question of which should you do more of, and how do you make sure that you're guiding in the right direction. So to me, it's much more about the iterative involvement of different data types and how do you fold that into the right recipe, how do you make sure you're guiding towards an outcome that you're looking for. Also, how do you know how to judge what that outcome looks like? I mean, we were chatting about this before, that the idea of conversationality and naturalness in audio is very, very difficult to quantify ahead of time. So you almost have to say, can I first define what it is I'm looking for? And if not, then man, I've got to try a bunch of different types of data until something just feels natural. Very similar for browser use. It's how do you teach a model that it needs to explore a UI in a certain way? Well, you kind of have to just iterate on a variety of different examples how to do that. And as soon as you start seeing something take off, that's sort of where you can start doubling down on. And to me, it's the signal of how is the model responding to what you're feeding it.
So about 10 years ago when we started data labeling, it's very simple questions. This is a cat, that's a dog. Now you're getting, PhDs coming up with math questions. How many PhDs are out there, and how do we think about as these intelligence progress, where are we going to get all of that additional human intelligence?
Yeah, so as you mentioned, if you look back a few years ago, the main type of labeling that was happening was very basic, determining whether a certain image is a cat, determining whether a stop sign is actually a stop sign, and so forth. And now it's very much fundamentally shifted towards PhDs defining extremely difficult prompts that models fail at, which is becoming obviously more and more difficult over time, and defining optimal answers to those. And of course, PhDs, whether it's in math, finance, or whatever domain, can also get things wrong. So there's you have to also evaluate the kind of objective nature of those PhDs actually coming up with answers. So then there's a problem of how do you run QC on problems that are so difficult already. So now you start to kind of explore areas of peer reviews, which are you have different PhDs look at the tasks of another PhD to kind of determine whether it's on the right track. I think right now it's becoming much more difficult to stomp models in kind of static prompt output pairs. But I think an area where models are still really struggling in is when you have multiple actions in a row and you have to, the errors, even if the error is kind of small in the first action, let's say 10% error, if it has to do 4 actions in a row and each time there's a 10% error, those compound really quickly to a large failure. So this is where our environments are coming into play, where domain expertise are really important, but also the kind of sequential nature of those tasks and the architecture of that are also extremely important.
Anyone else want to add on to that?
No, I mean, I think just like Ollie was saying, right? Like the whole process around thinking about data is very complex, right? You know, you can't just say like, you know, I'm going to go and like find labelers to do this task. I think that, you know, especially the way that micro ones are thinking about it is like, you know, how do we actually become very nuanced and very specific about the way that we go about like defining what a task is, you know, think about like, you know, how we should actually be labeling our data, like who are the experts, how do you know, QC the experts, like this is not like a small operation, right? I mean, like, you know, you have to like think very deeply about this. I think that's really important, you know, something that I think, you know, micro team is doing really well. And I think, you know, for folks that are training models, like, you know, it's very important to think about this too, right? Like you know, because at the end of the day, you know what is very important for your users, your customers, and how are you actually trying to like collect the data that, you know, fits the bill. So it's important, you know, for there to be like a strong partnership here, right, between, you know, data providers as well as like, you know, model trainers.
And when you train these models, obviously you have teams that are working much more closely with data. You have researchers training the model. You have, you know, people down in the product who are working more closely with customers. How do you make sure that all of these teams are working together so that your product people know what kind of data, you know, they would need, or your data people know that what kind of data they need to, you know, procure in order to fit specific bills that your product folks are trying to target?
I'll take a first pass on that and say you can't actually separate. Like we'll have a bunch of tasks that go get labeled. We'll have the data team look at it first, then we'll have the researchers look at it. They'll just gut check. Do you think this is actually going to fit the structure that we're looking for? We've got PMs will go and gut check whether or not it's appropriate prompt, whether that prompt is realistic for a customer. Also, then you kind of have this tension between, do you want to make your customers perfect at prompting? Is that your job? Or are you there to make sure that a poorly written, very poorly written prompt ends up producing the intended outcome? And I think going back to the point about QCing and peer review, you end up in this world where it's like, okay, can I get 5 reviewers out of 7 to all agree what the task was, how to do it? And you're shaking your head because the answer is no, right? And so that almost becomes a whole separate bar. Like, where do you set human intelligence relative to model intelligence, relative to customers' expected intelligence? So I think that there's multiple layers of planning, because you're right, these are multi-million dollars, tens of millions of dollars on every one of these runs. It becomes very, very difficult to think that many steps ahead. And I think, to the main point, you can't separate. You have to have the whole team sitting in there from different perspectives, bringing their own point of view.
Yeah, happy to add on to that a little bit. So I think the flow always starts with the product team kind of determining user needs. And in fact, it starts with the user demand. So, you know, when a certain app goes viral and a foundational model provider may focus on that foundational model for that app specifically. So the user demand kind of generates the product team's focus. And the product team essentially has to work very closely with research teams, where the research team actually figures out how to improve the models and the sort of architecture to do so, which Cartesia is quite good at. And then from there, there's this kind of the data operations team that the research team has to work extremely closely with. And I think one of the misconceptions I think is that researchers sometimes are kind of they stay away from the data, and I think this is the route towards actually not training good models. I think researchers should be very much in the sheets and data platforms that have the data and really look at not only sample sets of them, but more than just samples. And I think that sort of product, user demand, research, and data operations team is what results in really good models.
Yeah, just to chime in a little bit more, I think like everything that's driven is usually from evals, whether it's not you that's evaling, it's your manager, your leader, or your customer, if your product's out there already. And those evals will always drive like what the data needs to be. So like if you're hearing from your manager, like, all right, this model's like terrible at like selecting a color or something like that, something so basic, like then you kind of gather around that. You're like, all right, we gotta go create some training data so the model gets better at these. These are like easy evals that we need to patch, and then customers will also need to be like the ultimate test. And then yeah, I think we'll also probably talk that the customers' bars will always be increasing. So the eval is always just like keep following that basically, and that kind of guides the direction of what researchers need to be thinking for data.
So I think at this point, RL environments have come up a couple of times already. So maybe, walk us through how to think about where to use human data, where synthetic data come in, where these, newer paradigms like RL environments should come in. How do you guys think about that?
Yeah, happy to take a first shot at this. So I think the way we look at it is that RL environments are really largely human data as well. Of course, there are different architectures of them, and you can argue that a lot of RLs is all of RLs sort of RL environments. So the distinction is not super clear, but I think the way that we define RL environments is that when you have an agent do multiple tasks and you have a state space that is finite and the action space that is finite, that is sort of an RL environment. And we look at it as the data that the initial constraints of the RL environment could be largely defined by synthetic data in most cases. But in a lot of cases, the edge cases, or really the actual cases that define a good agent in really any use case, have to be generated by human data. And if you have some synthetic data that kind of define the cases, you still have to have humans in the loop kind of check those. And so you're back to human data in almost every case. So yeah.
I'll just double down and say, if you abstract away from human data, if you think of labeled data versus human intelligence that's imbued in the data or the RL environment, you get exactly to that. It's like every aspect of the gym has to be imbued with human intelligence. We were joking earlier about like if you're trying to create a synthetic version of the United flight booking app. Okay, cool. I start off by thinking I need to figure out how to book a flight from here to here. So I know kind of the elements that are going in there. But then going back to this, like everybody has to be in the room. If you're not thinking through the actual use case, the actual use case might be on the end of a customer support chat, somebody wants to change their billing address. Whoa, that's not in the RL environment. Human intelligence had to be there at the beginning to say this is a likely use case, and this is the path the agent's going to go through to accomplish that. Therefore, there must be something there. It can't be an empty element that's sitting on the screen. You've got to actually build it out with real data. And so whether or not it's a labeled data or whether it's the human intelligence or the QC process of going through and creating these, you kind of have to imbue every aspect of it with this intelligence. So that's where, at least we're looking at it, it's like every single aspect here has to be built in with human intelligence, otherwise you're going to be creating these agents or models that don't know what they're doing. Right? They're limited by what we've provided them.
Yeah, just to add one more point of view, I think that the QC process is extremely important because you'll try to create some RL tasks, but when you actually train a model on them, you might not be able to catch when reward hacking happens. And I think that's going to be a very bigger issue that happens as people are doing more RL. It's like you create some training data, you'll have like a reward signal, but it's very hard to tell what that reward signal is actually teaching. As like environments become a little bit more complex, it's less easily verifiable. And we've already seen that with sometimes with computer-use agents of like it's warning something that you didn't expect, but you thought you would have caught against. Like just to give one example, like if you want to have like a model like recreate a PowerPoint or something like that, it can just copy and paste the image that you give it, and even if you want to try to like guard against that, you can find other clever ways. So I think like reward hacking is also going to be like an area where people, like even researchers, need to just like have their eyes on the rollouts and the examples to see what the model is actually learning, what behavior is being incentivized, because it's really easy to miss if you're actually doing like the training and trying to just create data just like from scratch.
Yeah, I mean, I think an important thing to think about here is also like scalability, right? Like, one of the things that you often want to do is, of course, you want to use as much synthetic data as possible, right? That's I think where everyone is really trying to go. But at the end of the day, like it's not just the feedback that you get from the humans. It's about like how do you make the humans like actually be able to isolate what kind of data, what kind of synthetic data is like most valuable for the model. Now, the question is, this is more like a meta level question, right? Is there like another reward model that's like better at this than, can you model like what human behavior looks like? I don't know if we're there yet necessarily, but I think this is where you can actually get a lot of signal from folks who have like very different sets of expertise, very different perspectives, right? I think something that you think about, especially when you're building like interactive machine intelligence, is like, people interact with the world in very different ways, right? It's not just because I speak in a particular accent, right, or have like a particular tonality to my voice, that's not actually the way that we would expect someone in India, right, to interact, right? Like the tonality, the way you talk, conversation flow is actually very different. So having the kind of humans be like the right model to follow, kind of based on the different regions that you're in, or like based on the different kinds of environments that you're really trying to get after, is like a very important model to be able to follow.
And maybe just following up on that point, obviously sort of the point of the discussion is very much focused on human intelligence, but as we move beyond, doing basic math or, recognizing whether something is a cat or a dog, we're also moving to the part of human experience that's not exactly intelligence. We talked a little bit about sort of the naturalness of voice, but there are also things like, I used to be a hardcore, finance analyst, and there are certain ways I want to use my Excel that I proud myself for. I work with a lot of lawyers, so I know that, they prefer certain clause to be written in certain ways, and that's what they're proud of. So as we start to move into these, parts of human experience, we can call that intelligence, but, really experiences that are a little bit more individualistic. How do you guys think about pushing models to accommodate for that broader human diversity and idiosyncrasy?
Yeah, I can start off. I think voice clearly is like a very diverse way of communicating, right? And so when you think about voice, or things like pop into mind, or like accents, languages, right, intonation, right, pitch, right, these are all like different qualities of the way that we end up speaking with one another. Emotion, right, emotional intelligence is part of this as well. I think a large part of building these systems is not saying as the model developer, like, this is how the world should look. It's about giving the developers or the users of the model the controllability, right, or the ways of prompting the model in a way that gives them what they want, right? It allows them to build the kind of experiences that they want. This is something we think about from first principles, right? It's, of course, Cartesia, known for incredibly fast models, a lot of like very low latency, generate your voice the fastest kind of thing. But a large part of it is also like, how do you actually make it easy for other folks to do things like pronounce, words in a very custom way, right? Process, pronounce different, right, in American and British English. And how do you actually build this level of intelligence in the model? And so I think it's actually very important to recognize that the world is very the way that people interact, the way that people experience the world is very bespoke. It is something that should be personalized to some extent. And how do you make that process easier for users? I think those are the kinds of long living intelligent systems. Like, that's what I define as intelligence, right? You can keep adapting these systems to how a particular user ends up interfacing with it.
I'll add to that. I also distinguish between things that are, to your point, like potentially introducing friction, right? Like if I need to interact with somebody else from a different culture and I'm trying to do that in a verbal way, it's difficult to do that assuming one or the other culture, right? But also back to your example, there's an inherent friction that you're actually relying on when you say, I have a special way that I want to write a contract. Well, you're depending on the fact that you as a human need to spend the time to begin sitting down and writing that contract. That gives you the time and space. You're actually relying on the friction of that being a non-automated task. For you to say, yes, I've now done this very painful thing so many times that I love my one perfectly crafted clause for, most favored nation, right? I think for businesses, they need to think through, are they in a situation where they may be causing friction, in which case you absolutely have to go to the ends of the earth to think about customizing to every single user. Or are you in a situation where you're actually about to have quicksand, like all the friction goes away? Do you even need to worry about the way that one lawyer wants to craft something versus thinking instead about, okay, this agent's going to be drafting, that agent's going to be reviewing, that agent's going to be negotiating, all of it's going to be done, and we've just got summaries sitting back here to decide if this is a good deal or not. I'm not saying one or the other has to be true, but I think it's worthwhile looking at, are we going to the ends of the earth to try to customize for our customer when their whole need, the whole basis on which that they have their special way of writing something is just going to disappear versus being accelerated.
Yeah, just to add a little bit to that, I think it comes down to two main things to allow for, to be able to essentially take a lot of viewpoints in place as you train models. The first is defining the initial eval structure that is well encompassing, and then the second is trying to hire experts that are diverse in nature, are from different countries, different backgrounds, different seniority levels, and so forth. And I think that the example that I like to use is for our product Zara, which is how we interview folks how we interview experts to train models. One of the evals that we have is kind of looking at the intelligence of the actual interview system, which is how well is it conversating and how well is it asking questions in terms of relevance and kind of domain specificity. And so one of the main things that we do for that eval that we run is we ensure that the domains that are covered are very diverse in nature. So we have we are covering physics PhDs as experts that are kind of evaluating the AI interviewer in very complex physics areas. And then we also have sales managers and SDRs that have a completely different perspective and a completely different interaction with our agent. And I think the second thing is sometimes actually not related to the model itself or evaluations, but more so to kind of product fallbacks. I think when we think about the users that use Zara that go through an interview, the candidates that go through interview experiences, they are also a very diverse set of candidates. Sometimes they're folks in the US that are highly skilled. Sometimes there are lower skilled candidates in third world countries. And maybe the internet in certain countries are not as good as the internet in the US. So we have different modalities where it adheres to different kind of conditions of candidates, where we have voice mode that requires like lower internet bandwidth, and we have an avatar that requires much higher internet bandwidth. So I think the product decisions are also a huge part of being able to adhere to different set of users.
And then just the last point in terms of like styling, I think that outside of also just like general training for best practices, you see a lot of just like styling from in-context learning. Like, oh, if I like my essay written a certain way, I'll give you an example of an essay that I really liked, and then I want to like have it on a different topic in this particular format. You'll probably see similar things with like computer use agents, where it's like, oh, I like to go through my workflow like this. Can you do it in a similar fashion? And then so like outside of just like normal training, like in-context learning, I think is also going to be a very powerful paradigm of like having things in memory and in context.
As we're trying to wrap up this conversation soon, hopefully it's getting dark, people have a couple of drinks, we're going to do a few very quick hot rounds to take your hot takes on stuff. So the first question is, I already have friends who are very well educated, doing data labeling on the side as their hobby. So, in 10 years on LinkedIn, how many of us are going to be professional data labelers?
I think there's a good chance that a very large portion of humans eventually end up training models, and I think this is maybe at first glance this sounds kind of bad, but I think it can actually be a really good thing. If you think about agents fundamentally improving human productivity and really being really useful to humans in general, and then on the other side, if you think about like what does training models mean. It's really humans instilling their knowledge to this entity that can teach the knowledge of that one human to many more users. So if you think of like professors and PhDs, one of the main things they like to do is kind of teach the world. And what we've heard from a lot of the professors that work with us, a couple of which are in the audience, they tell us that their desire is to teach at as large of a scale as they can, to kind of tell the world about what they know. And you can argue that the best way to do so right now is by teaching these foundational models, which then, distill that knowledge to the world. So I do think there will be a large portion of the population that trains models, but I think that'll be a good thing.
I think everybody already is. We're just not paying attention, right? Every swipe, every email reply, everything you do is training a model somewhere. You're just not realizing it. Also, less dystopian. If we think about models as doing more and more human-related tasks or human-augmenting tasks, just imagine all the times that you are correcting, interacting with, teaching in your daily life with another human. You raise kids, you're teaching a model. You work with a colleague, you're teaching a model. You have an admin, you teach a model. You have a boss, you're teaching that model too. Like all of these are versions of teaching models. We're just not used to thinking them as digital, right? That's a real difference. I think everybody already does and will be in the future. We just won't call it data labeling.
All right, I know some of you guys work at startups, others work at bigger labs, but if today someone gives you $1 billion and asks you to train the next SOTA model, how you're going to spend that $1 billion? How much going to compute, data, hiring Ilya, or something else?
I think I'd give it back to the investors. $1 billion.
What's your hot take?
Yeah, I think put that money into video is probably the right thing to do. Maybe one last question. Obviously we're at an early stage of AI companies starting, and a lot of them are, have interesting gross margins. Where are we in the cycle? Should we care about it? Is it too early to care about margin? How do you guys think about that?
I will put it back to you. I think that the question is less about where we are in a hype cycle and more if we're going to see any end use. I happen to be at Amazon, last plug. We try to be very efficient, right? And that's the angle that we're taking. We're actually taking a very long bet that inference and overall compute cost will be a problem in the future. I don't think that we're anywhere near that yet. I think most customers are looking for the highest quality model that they can possibly get at any given time for any given task. But at some point, the bill comes due.
Yeah, I mean, I think when we're thinking about I think when we're just generally thinking about why people are training models today, it's really for pushing the frontier. I think there's something I'm also, I guess, maybe more philosophical here, right? I think there's something kind of quite beautiful about what the ethos is behind why people are training models and the different ways that they're approaching it. I think margins are, I think naturally they're very important to consider when you think about the overall market, but I don't think it's something that necessarily needs to be over-indexed on. I think if we actually think about what we can do more as a collective and how we're actually pushing that frontier forward, I think as a community, as a world, we'll be in a much better place. And I think margins will naturally have to fall into place, right? So I think we should care about it, but we shouldn't use that as the only North Star that we're pointing to.
Yeah, just echoing in terms of users primarily care about quality, and that's why we as researchers and product teams really care about making sure our models' qualities are as good as possible. And so that's probably comes first before we start thinking about how we can reduce margins.
Yeah, just to add a little bit to that, I think we're taking the bet that foundational models are going to significantly reduce in price really quickly, hopefully including Cartesia's models, which we use. And I think that the sort of picture that comes to mind each time is if you imagine some frontier model, let's say GPT-5, and you think about the mini version of that, the order of magnitude difference in cost is often 10x, and the intelligence is actually not super different for most cases. So I think you kind of extrapolate that, if you go 6 months, the new mini becomes what is now GPT-5, and so you can assume that will probably drop by 10x. And so pricing right now, trying to have 90% gross margins or above, I think would be a mistake. I think sort of ignoring margins is actually the right way to go.
I'll wrap up with my thoughts here, and then I'll open up to the audience. I think maybe some of you guys are old enough to remember the good days of DoorDash and Uber and Lyft being subsidized by all the VCs, and we can just take rides and get food and all of that. And those are great days, and I think we're also enjoying the same benefits, including from investors like us to enjoy a lot of the AI products. I think the ultimate question is not what your margin is today. Obviously, I think the question is, as your customers, if they're throwing money to solve problems, how much real product market fit does that mean? When the money goes away, how many of them are actually willing still to pay for your product? So I think we're still very early in figuring out what is the right business model for this new platform shift, and I think most technology platform shifts usually also come with a business model shift that sort of matches with that technology. Sometimes it comes immediately with software. We figured out SaaS pretty early as a business model. Other times they take many years. For example, internet, it took a few years for us to figure out how well you can monetize something like ads, and that's still fueling a lot of the frontier AI experiments the society is seeing today. So I'm not too worried about the gross margin if I have to give a quick answer, but I am looking for founders who are very thoughtful about without that subsidy or without that kind of price, how many real users do you have? And today nobody knows the answer. We're still all exploring. But people who are very thoughtful and strategic about that, I think they have a very exciting long-term future. So, well, thank you so much for all of the panelists. Very exciting discussion, and I'll open up to maybe the audience for a few more questions before we start back to the drinks and the mingling. Any questions?
Mike.
I'll give you the mic, and you can pass it around to the next one.
All right. Hello, everyone. I'm Antoine Matthews, the founder of Damon Wilson Consulting. So I wanted to ask you all for individuals that's training the models or building the next models when we're thinking about emotional intelligence. What's some feedback that you can help individuals that focus on, as you all talked about? I think Micro One, you all did about 500,000 different prompts and evaluations to kind of get you all's AI systems to get to where it's going. But thinking about like, even somebody from Jackson, Mississippi, like training your prompts, being able to really bring like the diversity when we think about like that aspect. So my work with consulting is working with you all to continue to elevate like those progressions. So I guess like my questions to you all, people building these systems going into the next level of training the system of human intelligence, like what would you all encourage individuals to look at to diversify like that thought process?
Yeah, so I think in terms of emotional intelligence, it's still a really tough problem for models. I think it goes back to the data on who is kind of determining the labels for emotional kind of assessments. So if you think about like an interview context, one of the things that we rate in the interview is the soft skills of a person, and frankly, it's the part of the interview assessment that is the weakest based on how models perform currently. I think that the route towards improving emotional intelligence for models is increasing the dimensionality of the models, like how much input the model has to determine emotional assessment in any sort of context. And I think the second thing is any agent that requires emotional intelligence, we should not force the humans out of it. Again, in the recruitment context, what we care a lot about is are recruiters being the ultimate decider of whether a candidate gets hired or not for a given job. So the recruiter looks at a report that the AI system gives the vetting results for, and then the recruiter ultimately looks at portions of the video and sometimes even does a call with the candidate before determining whether that candidate meets the actual technical skills, but also the emotional soft skills. So I think not removing the human aspect too early is a hugely important part of this as well.
Yeah, I mean, I think emotional intelligence is critical, right? When you're thinking about building some of these models. I think the approach that you have to take there is, maybe a little bit, at least right now, maybe a little bit more piecemeal, right? I think you might have multiple models that try to characterize, what is happening, right? Or contextualize what the conversation is, or how they're reacting on video. I do think that there's a world that we're moving to where all of this is like a much higher order understanding, right? I mean, I think there's many of these different terms out there, right? Of what intelligence actually means. I think emotional intelligence is something that's incredibly hard to describe, right? I think with mathematical intelligence or scientific intelligence, you're okay, I here are some tests that clearly that if someone passes, it's at least showing that it's a step function improvement along some axis, right? Whether those tests are good tests or not, can definitely be argued. I think emotional intelligence is just a very nuanced thing to be able to capture. And so when we think about evals, when you think about how people should actually, how do we actually know if this system is good or not? I think that's when you have to really think about who are the people that you want to be the ones as the initial stakeholders for evaluating these models. How do you make sure that your model is actually customizable or dynamic enough to be able to handle emotionally intelligent enough, right, to be able to handle these different situations. I think that's something we're fundamentally very interested in, and I think the future it will be a lot brighter, when we can get better at modeling that. It just gives us a lot more axes of being able to interact with the world around us.
Other questions?
I do have a question.
All right, last question, and that's on a high note.
I do have a question. When we move from journalists, annotating an image instead of cat, instead of dog, and then we start working with subject matter experts, actually voice coaches, medical doctors that really need to spend time, they need to do research on top of their current routine, which is most of the times busy. How do you see the challenges of keeping that data accurate and keeping experts incentivized to actually do a different type of work that they're used to do on their day-to-day basis?
Yeah, it's a great question. So I think a huge part of what defines really good data is obviously the brilliance of that person that is defining that data, but also the enjoyment of that person. Like, is that person actually enjoying the work? So, I think for Micro one of the main things that we focus on in our vetting and matching process is we kind of look at two dimensions. One is, of course, are they a good fit for the job in terms of skill sets? But also, we try to predict, which is a really hard problem, will the person enjoy the job? Because that will affect the quality of data very largely. And then what we try to calculate on the actual job is also those dimensions, which is ground truth performance data, but also ground truth enjoyment data, which again is a really hard problem. And I think especially in the domain of really highly skilled folks, we have to put a lot of efforts in retaining them by making it essentially an exceptional experience, giving a sense of community to the folks that are training these models, and ensuring that there's a diversity of tasks that they do so that the one data structure that they've been working on for a couple of months doesn't become too repetitive to them. All these things are really important aspects of the enjoyment dimension, which improves model capabilities.
I'll add on to that and say we're definitely in a gold rush era right now where we need to have specialized firms like Micro One who are bridging this gap in understanding how to even get the right task, find the right people, vet them, QA them. This is really important work to begin to understand how to structure this data. But as I joked earlier, we're all already training models. And that was the era of, oh, I'm generating data. Let me see if I can do something with it. It's how do you make something useful out of arguably exhaust? I think the future is going to be when product teams take the learnings and start building it into the core of the product. How do I make sure that not only am I delivering something valuable as part of my product, but I'm delivering it in a way that the key people, doctors for example, that are using it in a way that they're explicitly generating structured data or unstructured data in a way that I can then turn it back around and make a better product for them. So I think that's going to be the next evolution. We started with, what can I do with this? Oh, I've got extra. To, oh, I've got to get more. Let me just do some work specifically to solve this problem. And I think eventually we'll get to this point of how do we build this in intentionally, not by accident.
I'll just close it up by saying, if you're building a company like that, please come and talk to me. All right, thank you guys so much for this great night. We'll be around, hang out, and ask questions and enjoy some food. Thank you so much.